Hello, everybody. Well, this video is about Lab 3. Lab 3 is where the labs start to get really interesting. In Lab 1, we started messing around with Linux, and we started figuring out how to do a few configuration management exercises. In Lab 2, we deployed a monolithic web architecture with some content in it, so it could. I'm sorry, that was Lab 1. Lab 2, we deployed our Siege load generator and our monitoring architecture. Well, that was just getting ready for the real uses of our system. So this Lab 3, is where we start to actually make real use of the system. So we're going to use the work that you did in Lab 1, the monolithic architecture, and Lab 2, where we got Siege and we've got our monitoring software. But now we're going to make it interesting because we're going to add multiple web servers to that architecture, not one. We're still going to have a monolithic application, so everything's going to be in one server, but we're going to have 3 or 4 versions of that one server. Then we're going to have a load balancer that sits out front of that architecture, accepts incoming connections, probably from Siege, and then pushes them out to one of the 3 monolithic web servers. So in this little lab, you're going to write the scripts that generate more than one version of your web server, which, that's normal procedure because, if you only have one of any sort of server, then, you don't gain much from going to configuration management. We're going to have you generate multiple versions of that, and you're going to have to write the Ansible code that makes a load balancer work. Now, I don't care which of the load balancers that you use out there. The big ones these days are Nginx and HA Proxy. Either one of those is fine, and whichever one you want is fine also. So this is kind of the architecture that we're building, where we're going to have the internet connection coming in here. If you have built, I wanted you guys to build a virtual router out there. I think some people did and some people didn't. Either way, I'm okay. Then we're going to have this load balancer. Then we're going to have multiple versions of these web servers. We're not going to have any back end on this because I just don't think we're going to get to it. And I don't know if it's really fair game of me to expect you to do some database work and to break all this stuff up and everything. So let's just stick with this for now, and we'll see where we go in the future. But anyhow, so something like this. Oh, and your Siege will connect someplace in here. So Siege will come in someplace in the internet side of things. It'll get forwarded through your router if you have one. Then it'll go to your load balancer, and then the traffic streams will be split up onto these 3 different versions of the web server. 3, 4, whatever you want. I don't care. Your Ansible server, of course, would be sitting over here someplace so that it can access all of the servers in your architecture and your monitoring software. I advocated putting your monitoring software on your Ansible server. If you chose to do it differently, that's okay too. But remember, all of these web servers and your load balancer all need to be monitored also. In the lab, I suggested that you come up with some small play or a role or something that could be included easily with all your future servers that would be the monitoring tools. If you did that, then you're going to get paid off on this lab because it's going to be really easy to add monitoring to all of these web servers in exactly the same fashion. And they'll all report back. So that was my goal in this, and if you did that, then you're going to get paid off for your extra effort in doing it that first time. So the main deliverable for this is to deploy those 3 or more copies of Explore California and your load balancer. That's the main thing. Now, let's see. So the ops team will be responsible for doing that and configuring all the servers and all that kind of stuff. And let's see. So, but we're going to put a little slight twist on this thing, and that's what we're going to do is instead of having the ops team's work automatically pushed into production, what I want you to do, ops team, is when you're done, think of the scripts and the architectures that you generated as what are called release candidates. So they're not really officially approved yet until the security team approves them. So until the security team approves them, they should be known as release candidates. Now, the SEC team has to think about what are the policies around this increased level of workload that we're expecting for our architecture. I mean, that's why you build a load balancer, and that's why you have more web servers. It's not because you want to have a load balancer and more web servers. It's because you're expecting an increase in workload for these guys. So the SEC team needs to think about it from that perspective. What does it mean when we start having greater workload flowing into our architecture? With a small scale architecture, you're able to get away with stuff. We're growing out of that. What should we do? Well, we should have load balancer, right? What are the security requirements around that load balancer? Now, if you look at this thing, there's a glaring problem. 2 glaring problems, really, but let's just call it one. And that's this load balancer. What is it? It's a single point of failure. There's no getting around it. If that load balancer goes down, you lose your entire web architecture. That's crazy. But that's where we are right now as an organization. So, SEC team, you've got a problem here. Now, you could get on your high horse and say, we're not going to allow this architecture to be pushed into production because we've got a single point of failure. But you'd be missing out on a whole lot of business. So you may, as the SEC team, decide, well, we're going to have to live with this load balancer, but what can we ask our operations team to do to make this better? Now, you could ask them, and if you've got an ops team that's really into this, you could ask them to get over this problem of a single point of failure. That would be fine, and have multiple load balancers that would fail over to each other. That's fine, but that all depends on whether your ops team is up for that or not. Now, by building this kind of an architecture, we overcame a huge single point of failure that we had in LabThree, and that was that we only had one web server. At least now, and this is the way that policies get better and better over time. You address the needs as you go. But now we've got 3 web servers or more. And if any one of those web servers goes down, our load balancer should be able to pick up on that pretty quickly and forward the traffic over to the remaining web servers. That's the way it should work. But the question is, does it work like that? And SEC team, you may want to develop a way to test it. Does the load balancer automatically handle failed web servers? If it does, so much better. If it doesn't, that's a problem, because now if everything fails when one web server fails, you've just made the problem 2 times worse, because now it would only take one failure among 3 instead of one failure among 1 to bring the whole architecture down. That's even worse. So anyhow, something to think about. So let's see. So okay, so here's a little flow chart around this whole notion of what happens, how do you decide if this release candidate should be pushed into production. I'll let you read through it, but it's basically got an ops team side and a sec team side, and this is one way to think about what do you do if there's a problem with the work of each other. And let's see, so ops team outcome 1 is your Visio drawing, and we've got the same set of documents. You've got the project plan, which should be done first. You've got the ops team report of functionality. You've got the sec team report of functionality, and then you've got the group reflection report. So the standard 4 documents. Let's see. All right, so we got that. Multiple web servers and load balancers, and then more about release candidates, the deliverables, and then sec team, this is what you need to do. And I think I've already talked about most of this. Where should your security policies come from? Last time I gave you a nice little website that said, these are the security requirements of an Apache web server. Now, I'm not going to do that for you this time. Hopefully, you've picked up between the policies that I wrote in the first lab, second lab, and the ones that you found in that website, you should know a lot more about what to do around security policies. So you can figure that one out. And let's see, and then we've got our sec team outcome 2, and in outcome 2, and ops team also, we want to use the Siege architecture that you built last time, the load monitoring architecture that you built last time, and I want you to try it out. So, but there's a difference now. Last time we only had 1 web server, so 100 concurrent connections was probably a pretty heavy load for it. This time we've got 3. Does that mean we can have 300 concurrent connections? I don't know. But your Siege architecture will certainly generate that many, so that's not slowing you down. You could easily test this to see what kind of a load, this expected load, this guy supports. And then, from a security perspective, if let's say you said 300 concurrent connections, whatever you want is good. Look at your monitoring architecture, and if your architecture is close to maxing out based on your monitoring software, that at 300, what you have dubbed your expected load of 300 concurrent connections, that's not good. So you may need to add a 4th or maybe a 5th web server. Then you should be looking at that load balancer and saying, how's it doing in pushing these connections through? Does it have the sufficient capacity to do that? Or is that now going to, be a problem for you? So, think about this. Use the Siege architecture that you built. Use your monitoring software. Think what looks reasonable. If you're at 50% load on each one of those web servers, is that reasonable? Is that a load you should expect it to be able to handle? Or can it go higher? Or should it be lower? That's up to you to figure out and do some research and see what you think. So I hope you find this to be fun. I think it's a useful and interesting lab, and I hope you enjoy it. So take care, everybody. Bye-bye.